Chapter 12 Friction. The main topics that are covered in this chapter are: first, force of friction; second, factors affecting friction; third, friction a necessary evil; fourth, increasing and reducing friction; fifth, wheels reduce friction; sixth, fluid friction. These are the topics covered in this chapter. Let us consider a moving ball. If the ball is free to move by itself without any force acting on it, it will come to stop after some time. How it comes to stop by itself? Think of it. Consider another case. When we step over a banana peel, what will happen? We slip and fall, isn't it? Why is it so? Take two books. Overlap the alternate pages of the books. Try to pull the books apart. We can see that it is very difficult to pull it apart. Interlocking of books by overlapping the alternate pages of books makes it stronger. When brakes are applied, vehicles usually comes to stop. In all these above examples, we can see that some sort of force acts between the surfaces. What is that force? We can look into it with the help of another simple experiment. We are going to do a simple experiment. Place the box on a table. Try to push it from the left. It moves rightwards and comes to stop after some time. From this, we can guess that a force must be acting on the box which tries to oppose its movement to the right. That is, when a box is pushed from left, it moves to the right and comes to stop after some time because a force opposes its movement. Similarly, push the box from the right. It moves towards left and comes to stop after some time. Here also there must be a force acting on the box which opposes its movement to the left. Analyzing all these examples and experiments, we can come to the conclusion that a force must be acting on the box opposing its motion. This is the force of friction. That is, friction is a force that is in opposite direction to its movement. Friction is a force that is in opposite direction to its movement. This picture helps you to understand the direction of force of friction in a simple way. The force of friction is opposite to the direction of motion. From this picture you can understand the fact. Characteristics of friction. Friction opposes the relative motion between surfaces of moving objects. The force of friction always opposes the applied force. The next topic is factors affecting friction. What are the factors affecting friction? There are some factors which affect the frictional force. What are those factors? We can study that by conducting some experiments. Take a brick tied to the hook of a spring balance. Place the brick on a surface. Pull the brick by holding the other end of the balance. Note the reading of the balance. After that, wrap the brick with a polythene bag and try to pull it by holding the other end of the balance. Again note the reading of the spring balance. Wrap the brick with a jute bag and pull it. Note the reading. Compare the three readings of the experiments. You can see that there is a difference in the readings of the balance. The inference we can draw out of this experiment is: first, there is a difference in the reading of the balance. Second, it gives the measure of friction between the surface of the brick and floor. Third, friction is not the same for all surfaces. Fourth, it depends on the smoothness of surfaces. Let us do another experiment. Let a pencil cell slide down an inclined plane to a smooth surface like table or tile or granite or marble. Note the distance from the bottom of the inclined plane to the point where the pencil cell comes to stop. That is, this distance is to be measured. Now, spread a piece of cloth over the table and then allow the cell to slide down. Again, note the distance it covers. Repeat the experiment by spreading a carpet on the table. At last, spread a thin layer of sand over the table. Repeat the experiment. Again, note the distance it covers. We can see that the distance covered is large on smooth surface and it decreases as we change the surface. It is very small on sand. That is, we can see that the distance covered is larger for smooth surface, a bit smaller for cloth. Comparing to the cloth, the distance covered is much more smaller on carpet and the distance covered is very small on sand. You can see that distance covered depends on the nature of the surface on which the object moves. Force of friction is greater for rough surface and it decreases as the roughness decreases. That is, distance covered depends on the nature of the surface on which the object moves. A penguin can slide easily through ice because the surface of ice is very smooth. But it is difficult for the penguin to slide on sand as the surface is rough compared to ice. We have seen so many of examples and we can see that in all these cases friction arises. But what is the reason for friction? How friction arises? And what is the main fact behind friction? We know that friction arises only when two surfaces are in contact. So, the friction produced is due to irregularities on the two surfaces in contact. Friction is caused by irregularities on the two surfaces in contact. Every surface contains irregularities. It may not be visible to our eyes. Even very smooth surfaces also have minute irregularities. That is, almost all surfaces have irregularities. How these irregularities cause friction? Look at the picture. Look at the pointed ends of the two surfaces which interlock while moving. That is, the pointed ends or the irregularities of the two surfaces interlock each other while moving. This interlocking blocks the smooth movement of the two bodies. In this way, irregularities cause friction. Irregularities lock into one another. So to move an object over a surface, we have to apply a force to overcome the interlocking and this force is known as frictional force. Rough surfaces will have more irregularities. So it will have greater friction. That is, rough surfaces will have greater friction as it has more irregularities. As told earlier, smooth surface also contains few irregularities. Even very smooth surface will have minute irregularities. So there will be less friction compared to the rough surface. We know that even very smooth surfaces have minute irregularities, so there exists a small frictional force however smooth the surface may be. Now we are going to consider another characteristic of friction. That is, force of friction will increase if two surfaces are pressed harder. In the picture, we can see that it is very difficult to move a heavy box than a lighter box because heavy box presses harder on the surface and there will be greater friction. So to move the heavy box, we have to overcome that greater frictional force. We can understand this by this simple experiment. The simple experiment is drag an empty basket through a carpet. Do you find it so difficult? Certainly not. It is very easy to drag an empty basket through a carpet. Then try to drag the basket when someone is sitting on it. It is difficult, isn't it? You will find it difficult to drag the basket when there is weight or someone is sitting on it compared to empty basket. The experiment shows that when the surfaces are pressed harder, the interlocking gets strong. So more force is required to move that object over the other. While riding a bicycle, you may have noticed that it is a little bit difficult to start a bicycle. You may have you have to give more force to the pedal. But when the cycle started moving once, we need not give that much force. It feel easy to ride. So which one is easier, to start moving a bicycle or to ride a moving bicycle? Riding a cycle after it has moved is easy. From that example, we can see that the force required to overcome friction at the instant an object starts moving from rest is called static friction, and the force required to keep the object moving with the same speed is a measure of sliding friction. Sliding friction is less than static friction. Why is it so? When an object slides, there is not enough time for the contact points of the irregularities to lock each other. But before starting to move, the contact points of the irregularities are well interlocked. So, the sliding friction is less than static friction. Look at the pictures. When the body is at rest or just about to move, the frictional force acting on it is called static friction. When the body starts to slide, the frictional force acting is called sliding friction. And when the body is rolling over another surface, the friction produced is called rolling friction. Friction, a necessary evil. Why friction is called a necessary evil? First of all, we will try to understand why friction is necessary to us. The first point is, without friction, we can't hold any object. That is, to hold an object, friction is a must. To write in a paper, friction should be there between paper and pen. Otherwise, we can't write on a paper. Similarly, to write with chalk on a blackboard, friction is a must. The minute irregularities on the board rubs off some chalk particles while writing. To stand, sit, walk, and to stop a moving object, friction is necessary. Otherwise, we can't stand, sit, or walk. It will be very difficult for us. We can't ignite matchstick without friction. No building can be constructed if there is no friction. All these examples shows the necessity of friction in our daily life. Without it, it is difficult to do anything. These examples gives you an idea about the necessity of friction in our daily life. There are many more examples about the necessity of friction. So we have seen how friction is very necessary to our daily life. Now let us look how friction is disadvantageous or evil to us. It wears out materials like soles of shoes, screw, ball bearings, and many other things which are used in our daily life. Also, friction produces heat. We can feel that when we rub palms. Mixie jar gets hot when it is operated. So, heat generation causes waste of energy. So, friction is an evil. The next topic is increasing and reducing friction. How friction can be increased as well as how friction can be reduced. First of all, we can look how friction is increased to get better grip. For that, soles of shoes are grooved, tires of cars, trucks, etc. are treaded to provide better grip. Brakes in vehicles increase friction. Players rub their hands in soil for better grip. In all these ways, we can increase the friction. On the other hand, friction is decreased to increase efficiency. How friction is decreased to increase efficiency? Some examples. First, in carom board, sprinkle fine powder to decrease friction. When oil is poured in the hinges of door, moving parts of machines are greased in order to decrease friction. Then use of rollers reduce friction. Rolling friction is very much smaller compared to sliding and static friction. So use of rollers reduce friction. What happens when oil is applied between the layers of machines to decrease friction? A thin layer of oil is formed between the moving surfaces, so they do not rub against each other and interlocking of irregularities is avoided to a great extent. In this way, it decreases friction. The substances which reduce friction are called lubricants. Oil is a lubricant which we use in common. Grease is also a lubricant. These lubricants reduce friction between two surfaces. Like a liquid lubricant, there is solid lubricant also. Example for solid lubricant is dry graphite. A hovercraft uses air cushion as lubricant. The air cushion below the hovercraft acts as a lubricant to reduce friction. How wheels reduce friction? The next topic is wheels reduce friction. How? When one body rolls over the surface of another body, there will be a resistance to its motion. This resistance is called rolling friction. When one body slides over the surface of another, the resistance to its motion is called sliding friction. We can see that rolling friction is less than sliding friction. That is why we use wheels to reduce friction. Since rolling friction is less than sliding friction, ball bearings are used between hubs and axles of ceiling fan and bicycles to reduce friction. Fluid also exerts friction. This is called fluid friction. Air, water, and other liquids exert friction when objects move through them. This frictional force exerted by fluids is also called drag. Birds and fishes are of special shapes. Why? When they move through air and water respectively, they have to overcome fluid friction acting on them. So, to minimize friction, they are of special shapes. Aeroplanes, ships, and all other vehicles are designed to have shapes which reduce fluid friction. Shape of aeroplane are similar to the shape of birds because it is provided such a shape to reduce friction, air friction, that is fluid friction. Similarly, shapes of ships are similar to that of fishes. This is also to reduce fluid friction, that is friction due to water.